will have the quiz easy, and then everything will be there. And alhamdulillah, just now I read a question in our chat room. I realized someone is asking that I should give even a question. And exactly what I'm trying to do. Giving a question is not enough. I know if I give you a question, but to even solve a question with you, that's what I like. To at least I itemize most important focus question and then try to solve it with you. So that's why I call this class. So thank you for coming. And then without any further description, I think I will go straight to the point. I have already sent you a slide slides of the lectures that I had this morning and this afternoon. So the end of the, okay. I'll be saying any other question, because somebody asked a question that am I going to give you a question? Not only give you a question, I'm going to even discuss a question with you. That's what I'm even planning on the 20th. On the 20th, at least question will be discussed with you. That, but I will even start doing it today. But today, because I need to cover one part of the course, so I will focus on covering part and the question. So, any question?
No, sir.
All right. So let's go ahead and start immediately. So let me share my screen. Okay. Right here. So if you're seeing a lot, I didn't record as I just come back, and then maybe if I will say just maybe I think I just in these questions. Ask them these two questions. Okay. But before I ask them, first, what we discussed, we review what we had in the last class. Our last class is discussing in general about the job of a transport layer, what we had in the last class. All right. So when we are discussing in general about the job of transport layer, we specify that transport layer actually is very, very crucial. And then we also specify that within this transport layer, many things happen. But then 4 important tasks. These tasks, we summarize it. Really, you hardly find someone giving you like this. People mix the detail. But I just summarize it and put it as a point so that you will have a flow. You will assume beginning to the end. So in my own summarization here is on the assumption that this is number 1 is the beginning and number 4 is the last. So it means in transport layer, the beginning here is what we should have first. The beginning is the most important thing. The beginning is the port establishment, then followed by segmentation, then followed by sequencing, and then finally movement. That's exactly how it flows. This is exactly how you can trace the job of a transport layer. It first begins by assigning port number to any of the application in a communication session. Then it have that are needed to pass through, and then assign number to each of the piece or of each of the parts that we can call it or segment. Then finally move them. And when it is moving them, it either move them through TCP or UDP over here. And we summarize in a straight point that TCP is a protocol that will give you an assurance that your message will be delivered. You will get that assurance. You will be certain to use TCP that your message will be delivered. And before it sends this message, it first establishes connection. And when it establishes connection, then it now sends the message. And we say that the process of establishing this connection, it is what we describe it as a three-way handshake. And this three-way handshake over there, if everything happened fine, and if in all the section, if everything happened fine, then everything is good. But the moment there's a problem, then we need a flow control, a huge that opportunities. I know the students, the computer science student, you cannot escape this flow from earlier on. But now that we are more practical already, we just talk about just it. And finally, UDP. UDP, we say that your message could be delivered. And then next, it does not establish connection before sending the message. So it looks like it has something opposite. What they have, or move a data, or they try to take a data from one point to the other. So this is what we discussed in the last class. And of course, we know that this is a general background about the transport layer. Then when we went to the TCP header, we realized the most important part of those header, there is port number, and also, of course, there is destination and source port number. That's what we see in the header. Then we went further and see that there are information related to segment and also information related to sequencing. And finally, the three-way handshake with some other control information. In UDP header, there's almost nothing. It's only a description of the ports, and that's it. Then that's all. And that's why we say TCP is a reliable means of communication, but it's very slow. UDP is the faster means of communication, but it's it's unreliable. That's what we just say. So this is what we just say in summary in the last class. Okay, now, since we say that what we needed is more detail about this, more detail about this, more detail about this, more detail about this, and then we end the section. So it's like more detail about them that we have and end the section. All right, later I will just, I think this is the only thing new, but when we reach that point, I'll just tell you what to do. So all lectures of today goes directly into the NetAcad. So I utilize NetAcad today for everything that I do. All right. When we go into the NetAcad, this is the beginning of the transport layer. If you could see, where is the transport layer? Is module 14. And you can see over here, they start with the role of transport layer. So in summary, this is what we just described. In our own way, I believe it's better. Over here, there are a lot of stories, and they didn't arrange it in the way that I arranged it over here. So in their own arrangement is different. The responsibility of transport layer, they should have arranged it in a way that I say, port establishment. So in this port establishment, then they come to sequencing, segmentation, and all this, but they didn't do that. But it's similar approach. So it means all that you need to understand first is that in transport layer, first there is an application that we need to recognize. If we recognize this application, then we assign them port numbers. As simple as that. That's the first step. When we assign them port number, the moment we are about to transmit them, then we divide them into sequence. And once we divide them into sequence, we divide them into segment. Then when we divide them into segment, the segment, we assign it a sequence number. And when we assign them a sequence number, then finally we are done. So with that, then we start moving them from one point to another. We either move them through TCP or we move them through UDP. Either one, there is no problem in terms of movement. So this is what we have over here. So this is the detail. I think we talk about, of course, the transport layer protocol. We talk about it. There are only two most important protocols, TCP, UDP. We talk about the TCP here. We see some simulation about this. We talk about UDP also. We see some simulation about that thing. And then now over here, we see some right related to the transport layer. And then finally, we come to the header. we see the TCP header, I remember, and we see the TCP header fields. We see the detail over there, and then we see the application that uses TCP most. So this one most, there are others that use TCP. Similarly, we see the UDP header, of course, so straightforward, and see the UDP header fields, which is given over here. We see the application that uses the UDP, which is so direct, also so straightforward over there. So today, we are going to start from this part, which is about port number. We already talked about it. We said that it should be there. So port number, in this port number over here, so the first part of this port number is about trying to figure it out. You could see this is its representation in both IPv4 and IPv6 header. So no. In both TCP, IP header. This is the representation of port number. We have source and destination, and each one of them have 16 bits filled in the header. That's number one. Then number two, what we need to identify about this port number is that when we come to this slide, assume there is a transmission between a client and server. So there is a server here, but this server is containing two server applications, which is the FTP server and the web server. This is a combination of this. But this one is a single computer, and within it also it has two applications over here, which is the FTP client, and so it means ordinary person already have this application installed in the PC. PC that you are using now, where your web client over there, how can you represent the web client application in your PC? Web client. Thank you very much. You just say browser. Thank you very much. I really appreciate it. If you just say that's it. So it means if you don't never get away, that's exactly what it's saying over here. The browser that you have is a client. You expect that inside here so inside our computer over here is hosting this client over here. So the client FTP for this specific application should be able to read the server FTP on the server here. So it means this is a connection between one application and the application. You see? Similarly, the client for the web in this PC should be able to read the server of the web on this server over here. So the connection or the interconnection between application and application is what we describe, or it is what is the job of a port establishment. It's only have a connection for the FTP connection and also for the web connection are the same, except for the port numbers. Take example. This is the PC that you have. You have an IP address 192.168.1.5. And this is the MAC address of this PC. This is the server that you have. It have an IP address of 168.1. And this is MAC address. So there's a connection between this and this. We only need, this is the source IP address, we put it over here. This is the destination IP address, we put it over here. So the logical connection has been established. A connection for this is the source MAC address, we put it over here, and this is the destination MAC address, we put it over here. So similarly, in this web, it's a similar thing. The same source IP address, you could see over here, the same destination IP address, you go here. The same source MAC address, you will see it over here. The same destination MAC address, you will see it over here. So it means in both of these two connections, they are in the same address, they are having the same IP address, but the moment you reach port number, you will see that the port number, source port number of the FTP connection is different from the port number of the web connection. The source port number, the destination port number of the FTP connection is different from the destination port number of a web connection. So I would tell myself, oh, this is the only thing that differentiates them. So communication inside the server, they are different and they are connected differently. That's exactly. And that's why we have this, we say multiple separated communication. Of course, it is multiple communication, but they are separated. What separates them is only port number. As simple as that. This is the simple point that you can pick. The only thing that separates them is the port number. Simple as that. Otherwise, they have everything the same because it's the same host here and this is the same server. Did you understand this?
Yes, sir.
This is very, very, very important, really. Not only for just class or not for only for exams, but this is very, very important for knowledge. As far as knowledge is concerned, you need to understand this. Really, everybody need to understand this. In the moment you are curious about how you connect two devices using an IP protocol, this is where you are. Similar pattern applies to all other telecommunication communication. So in all telecommunication communication, you have the end device. If it is a sensor, also can have so many different modules. In sensor, we don't call them application. We call them modules. So this sensor will have different modules. Then probably the sensor or the server in the sensor or the cluster head sensor will also have different modules. And of course, but it is within the same unit. So this is just everything about communication. And I like you to know this. So now you understand that port number, this is what it is. All right, let's go in. This is the operation of port number. Now, the production of port number. How do we produce port number? Or how do we manufacture port number? We manufacture port number or Internet Assigned Number Authority produce port numbers. They are the one that decide. You see, this Internet Assigned Number Authority, they are the one that produce IPv4. They are the one that produce IPv6. They are the one that are responsible of sharing IPv6 and IPv4 to all parts of the world. And at the same time, they are the one responsible also of producing port number. They are the one also producing, responsible for the sharing of port number to all applications that runs on the network. You see, they are doing a great job. For you, you are only responsible to assigning or planning of only 2 campuses in your project. We just say, just plan IP address for 2 campuses in your project, but still some people are finding it very difficult. But these guys over here, they are doing it for the world, and they are doing a great job. So when they come to the port number, they say, okay, we consider that, of course, there are many applications. However, we know that there are applications that are in the world that use on that will not be more than this amount because we are grouping the application. In fact, if you could say in a real sense, we are supposed to only have 4 applications. The application that is under a image, the application that is under audio, the application that is under video, and the application that is under text. So if you have these 4 groups of applications, we give them each port number, then we are done. However, they go in within this application, they also subdivided, and then make the assignment. So this is even too huge. We are supposed to have 4, but they are having up to 65535. And if you could remember now, where I will have my exercise. 655, that means from 0 to 65535. Do you remember, did anyone remember this 655 when we used it last? We used it just recently. Where use it, this number? Who can remember where we use this 65535? We just use it. And I don't want to remind you where we use it. Who can tell me where we use it? Where do we use that number? Any idea? I remember I tell you that this number, when we are using it, there was one time that always
make size for transfer. Is that correct, sir?
I repeat again.
When counting one of the class we count, so got the max size. So if the bit size is over, it cannot be sent.
Okay, max size for what?
I don't remember.
Yeah, you are right. It's about maximum size. That's very, very good. I really like this. You capture the tips, remain the main body of this. That's true. It's a maximum size of one thing that we just talked about over here. We just talked about it recently. It's a maximum size. So what size is that? It's a maximum size that we just talked about.
MAC address.
What?
MAC.
MAC address, the maximum size is what? It's 15 what? 1518. That's the maximum size. Oh, sorry. You are talking about the Ethernet, right? So Ethernet over here is 15. That means you are talking about the Ethernet frame size. The maximum according to the Ethernet standard or according to the IEEE 802.3 standard is 1518. But this one is not 1518. So what is the maximum size representing this one? I need quick response. Say of course, it's a maximum size of something. So what is that thing? We just talk about it. And somebody say Ethernet frame, but it's not Ethernet frame. So which one is the friend of the Ethernet frame? If you can make a relationship between Ethernet frame in the network, which one are you going to make if you want to join a relationship, which one are you going to do with? Easily, a good relationship, a matching relationship. Which one will it be? Ethernet frame. Which one is going to be? Any idea of what? What is this size? Somebody says the maximum size. The maximum size of what? You see, that's the one I give exercise. You see, I ask this. I say, where does this number appear in IP protocol? Okay, this number, where does it appear? I do the same thing with section 2. Somebody say it's a maximum size of something. Maximum size what? I ask this question. Then the next question that follows, which I also ask, because if you could see number 0 through 65,035 ranges of port numbers. From 0 to 1023, we say they are described as the well-known port numbers. They are used for common or popular service. From 10 to 49151, we say they are reserved port numbers. And of course, like for example, this one is reserved for server. Then we have a private port number, which is from 49152 to the last port number. They are all private. So within these, then I ask again, I say, okay, in your exercise, from 0 to 1024, write 3 applications that uses any of the port within these. Okay, let me give you this exercise because this is the same exercise that I give to, I think, section 3. So I'm giving you 2 minutes to find out what is this. Or let me say 3 minutes. So take 1.5 minutes for each. You find the answer, then you voice it out. I'm waiting. Yes. Thank you very much. Packet one. But when you say packet, you need to define the full name. I like the full name. Packet. Just say IP packet. That's exactly. This is the maximum size of IP packet. As simple as that. If you just Google, you will just see. In fact, if you even Google this number, it will bring it out. And if you could see in the slide over here, since you have saved us, of course, this number, how do you think we get this number if you read this? From here to here, let me say, if you read from here to here, you will know how we get this number. How do we get this number? If you read from here to here, how do we get this number? If you read, then you get the idea. How do we get? Very good, 16 bit. If you convert the 16 bit, it will be what? If you punch it in your calculator, it will give you this number. That's the most important that you need to understand. All right, so this is all about this. Since one sister already saved you, let's also do this again. So what are the 3 other applications that uses this port number? Like for example, what is the current port number of the Google Meet that we are using now? At what port are we using this Google Meet that we are working now? What are the other 3? What is the port number of the Google Meet that we are working on with now? To tell you that many other applications have a port. What are the 3 applications, not the common one, but they are operating within, not the common we know is this was application, and they are moving either TV or unit is their port number. So now this, what other application uses port number 2104 that you know, or that you just quickly browse and see? Which one? No. So take any and search. Like for example, WhatsApp, Telegram, whatever you have. They are all these network applications. Search for them and then try to determine their port. So what's their port that they are using? Can anyone give me 2, 3? Any idea? Any idea? Any idea? Okay, I'm giving search. What is the port number of your that you're okay? So what did you to this group? Yes, that's it. So I don't need to waste my time to bring you that they're talking about real and they're applied. So you have to know that if now you are already in a network and if you want to open your command prompt up and then execute the command, then you will see the statistic of the protocol, IP, this is because it's IP address and port number. This is the instruction. However, when you see immediately you have a column, definitely what's in here is a different numbers of from all on IP address. So it means it is one single device, but is using 6 different applications. That means you open probably 6 different browsers. You are running 6 different browser app, not different browser. Browser address is the same, but then the port number are different. So this port number belongs to which category of port number? From this one, from the beginning to the end, belong to which category of port number? Which category of port number does this belong to? Any idea? Anyone knows?
Registered ports.
Registered port number. So don't make mistake of this and say, oh, I didn't see port number over here. See semicolon, like for example, in this, if you see, once you have this semicolon, the next thing over here is representing port number. But however, here we specify it. So it means if I ask you, what is -SSN? It's very easy. But this one, what is the port number of HTTP? 33? 433 for HTTP. Anybody with another number? 80. So you just say 80. So please, this is what we have in the port number. All right. Network security, because people use number to inject an attack. If this port is open, if I know this destination port is open, and especially if it is, I can directly bypass all this one and then inject an attack to this port number. And sometimes we can view which port is open, which port is by using a software called Nmap. Nmap is available. Please try to test it and see. So if you are interested in network security, you have no choice, but you need to at least pay attention to this category of the port number. All right, that's N. Then finally, now we come to the TCP. And now we already say that it is giving assurance and it's establishing connection. So if it is doing that, how is it doing that? First, of course, it's TCP, of course, enable, of course, the establishment. There have to be a port number establishment. The port number establishment, of course, happens here, similar to the diagram that I just sent it to you. These are the kind of procedure which is, of course, I know it's supposed to be 2, but they digest it into 5. That means at this point to this point to this point, if you could see, all these ones are all about requesting the port. And once you get the port, then now it is the response. So I see it as 2 things. You request to get the destination, and then you get it. How do you request to get the destination point? Port at land. application. Like, for example, I want to get to your WhatsApp. I also have to have a chatting exactly what is happening over here. So first of all, then the next thing, then I send a hi. Then if I send a hi, if you have a WhatsApp, then definitely it will go through that part, and then you will now respond because you received my WhatsApp. So that's in general way of trying. But however, when you come to theoretical way, it goes in through this way. Client first sending TCP request. Whenever you're sending a TCP request, then the first thing that you have to request for the destination part. That means the application first. You need to know the application. You have to request for that you are using. Then when you request here, you have your own source. Now you will see the destination port over here. Exactly a typical way of doing that. This is how to get the server. Already the server also have the port that we need to over here and put it as our destination port. Similarly, here you have port, then now you can be able to access the application of this HTTP and SMTP. So this is the first establishment of the connection. However, this is within the application level. Then when it comes to the communication level, there is three ways of doing that. The first way, we call it RTS. What do we mean by RTS? RTS means request to send. So first of all, in order to establish connection, there are some data that are sent over here, which we call them RTS data. That means request. So if you are a client A and you want to reach to server B, you first have to tell the server that I am requesting to send you a message. Think about this situation. It's like I want to send you a message, but I'm asking you. Some people others used to do it. If, like, for example, they want to talk to you, they will send you a message. They say, sir, please, is it a good time to talk to you? Then I say, okay, yeah, it's a good time to talk to me. So this is similar example. You want to talk to a person, then you send him a message that is it a good time to talk to him? Then he will reply by saying, yeah, it's a good time to talk to me. Or if you didn't receive a reply, let's say you say, sir, I want to talk to you. Then if I keep quiet, you know I don't want to talk to you in this way. So it means the connection will be terminated. However, in this case, it's also similar. If this one send a sync, which is a one-way message requesting to talk to B, then B will say, okay, you go ahead and talk to me, probably now or later, go ahead and talk to me. That is what we refer to as a SYN ACK, the way you see it over here, SYN ACK. So this is the second way. Then the third way over here, my request is being approved. But doesn't mean you already start sending the message. In my own case, if you say, sir, I want to talk to you, can I call you now? Go ahead and call me now. Okay, I will be calling you right now. Oh, give me 1 minute, sir. I will call you now. So this is the way. So this three-way handshake does not mean that you started sending the data. No, but now we already established or we agree that we will communicate. That is what is three-way handshake. Once we agree that we communicate, then we start communicating directly over here. And once the communication finishes, terminate the communication. How are we going to terminate the communication? Then I'll say, okay, I already finished. So, okay, that's all. Bye-bye. Okay, bye. That means you have to send a bye-bye to me that you are done. Then it means I will also say, okay, it's okay, but then the server now also started message will be the one to initiate the closing of the message. I am finishing, then the server will receive, okay, you are about to finish. Then now finally, acknowledge, I dropped, bye-bye, everything end. You see, this is the first, this is the establishment, and this is the termination. And with that, that's why we say we always So the Wireshark, this is my Wireshark file over here. If I should go and start, what do you call it, capturing. If I should start capturing over here, so it will take time to start capturing, but yeah, then this file is now my PCAP file. In the file, there is always a source and there's a destination IP address. Then there's protocol, then there's info. So I will be interested in looking at the protocol and the info. So my interest, I know the three-way handshake only happen in TCP. So first I need to go and examine in this protocol, where is my TCP? So now you can see that it started capturing, but it's not capturing TCP. It's capturing which is SDP. So now I have this one that already captured TCP, which is this one. You see this one, PCAP file that already captured TCP. Transmission number 50, 51, 52, 53. They are all on TCP. So if you could see 50, 51, 52, which is all on TCP. If you watch the information, you will realize that the first one on the 50 is sync, followed by SYN-ACK, then followed by ACK. It means this 1, 2, 3 is a three-way. And what happened here is that this is the first source. It initiates the transmission to this, and then this one, when it received the sync, then it's now become the source and acknowledge that it received the sync with the SYN-ACK over here. And then finally, now this source say, okay, now I'm ready to send. When it's ready to send over here with this ACK, the three-way handshake has already been established. Then now the first message that it sent a get me the message that that person sent over here. So now you can see this is the three-way handshake over here, and the last part of the sending of the data over here. So with this, in the exams, we will give you some file like this, but it's not that we 50, 51, 52 to have it as sync, ACK, and ACK. No. Sometimes the first one, 50, will be sync, but the acknowledgement might be even up to 55 or 56. And that's how it goes, because probably the transmission is very fast. As I send sync, other applications are also requesting a transmission. And that's why I cannot see them within a row. But this is where you can see it in a row, and then it will provide you with the detail. So the next detail is this. Let me go in over here. The next detail after this is that works in the video.
I have some screenshots of Wireshark architecture to show the process of TCP three-way handshake and the termination of the TCP and get an idea of how it's working. This mean before data can be sent or initiates that connection. When the connection finally needs to be terminated, for instance, to a web server, and you close the web browser, the connection is terminated with two-way handshake. A TCP three-way handshake involves steps: a SYN, ACK, and an ACK. SYN stands for synchronization, and ACK stands for acknowledgement. First, the initiating host sends a synchronization segment. The responding host sends an acknowledgement and its own synchronization segment, and then the initial host sends an acknowledgement segment. Hence the SYN and an ACK, and ACK. We can see that here at the top of this screenshot. If we look at the packet list window at packets 10, 11, and 12, we can see a SYN, and an ACK, and an ACK. If you look at the initial packet, the SYN segment up here at the top, we can see that the sequence number is 0. The beginning of a three-way handshake is a sequence number 0 because it's the first packet in the connection. initial sequence is chosen randomly at the beginning of each TCP conversation. This helps to protect against TCP connection hijacking attacks. Wireshark takes that 2-bit random number and converts it to 0. It then increments the sequence number. This makes it easier to defauler using the Wireshark program. Let's look at a few of the details of the initial SYN segment. Get onto the packet detail window, and we can see sequence 0, that it's the relative sequence number. Has been set. You can see one. In the next packet number, the server responds to the initial to the next screenshot, and now packet 11 is highlighted. The server acknowledgement. So the initial sequence with sequence for 0 has been incremented and acknowledgement 1 has been sent. We can see in the protocol details window acknowledgement number 1, and that is the relative ACK number. The server has also sent its own synchronization segment, and that number is 0, since it's the initial conversation going the other way. And that's a relative sequence number from the server. Here, the flags, both the SYN have both been set. In packet 12, which is step 3 in the three-way handshake, host 10.1.1 responds with acknowledgement. If we look at the details window, we see the acknowledgement number is 1, incrementing the server synchronization. Has not been set. This is the phase in the three-way handshake. Let's take a look at how this connection terminates. I'll go to the next screenshot, and you can see in packet 16 is communicating to the 1.1 and has set a segment with a finish or fin and an acknowledgement or ACK. In this segment, we have a fin, the fin, and the conversation. The acknowledgement flag has been set since the three-way handshake was first established, and in every segment sent thereafter, acknowledging that the conversation has ended. Two-way handshake, a fin and an ACK, and an ACK. If we look ahead in the packet list window, you can see that host 10.1 then sends the server its own segment, and then the server replies with its own ACK. So you have two-way handshakes to terminate the connection. Go back to the previous screen and take a look at the protocol details, the packet details. We see the flags. Notice the one for the acknowledgement or the finish. Or separate packet captures in one. Conversation and two-way handshakes. A fin and an ACK and an.
Okay. So any question here? Any question? Any question? Right, Alhamdulillah. Please take note of our quiz. Nothing much. So I just have to end the class at this point. Attendance code is SYNC. So please just go and type SYNC, S-Y-N, as our attendance code. All right, so everyone, see you after the break, inshallah.
Sir?
Yeah, right. Of course. Of course, don't worry about that. I think the only thing that I just, I'll do that, no problem.
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir. Assalamualaikum.